So now let's take another problem. So I am writing the problem here first. An insulated and insulated rigid tank rigid tank contains 2 mole nitrogen 2 mole nitrogen at 20 degrees centigrade and 200 kilopascal separated by a membrane from 4 mole carbon dioxide 4 mole carbon dioxide at 100 degrees centigrade and 100 kilopascal. The the membrane ruptures and the mixture reaches equilibrium and the mixture reaches equilibrium. Calculate the final pressure. Calculate the final pressure. Calculate the final pressure. Take CV of nitrogen equals to 0.745 kilojoule per kg Kelvin and CV for CO2 equals to 0.653 kilojoule per kg Kelvin. Now let's solve the problem. So I am solving this problem here. In that problem, 2 mole nitrogen is given. So first I will calculate mass of nitrogen. So that is mole of nitrogen into molecular mass of nitrogen. So the mass of nitrogen, the mole of nitrogen, that is 2 is given, molecular mass, that is 28. So the total mass of the nitrogen will be 28 into 2. So it will be 56 kg. Similarly, mass of carbon dioxide equals to mole of carbon dioxide into molecular mass of carbon dioxide into molecular mass of carbon dioxide. So the mass of carbon dioxide will be 4, that is mole, and it is 44. So it will come 44 into 4, it will come 176 kg. 176 kg. So suppose mass of N2, it is M1, mass of Ca2 is M. So during mixture, the temperature of nitrogen will increase and temperature of carbon dioxide will decrease. So we can say that during mixture, heat gained by nitrogen equals to heat lost by carbon dioxide. Suppose final temperature is Tf. I will write final temperature equals to T. So final temperature is T. So the heat gained by nitrogen, that is 56, is the mass, and C, that is the specific heat at constant volume 0.745 and T minus 20. Similarly, for carbon dioxide, mass is 176, G for carbon dioxide 0.653 into here the temperature will decrease 100 minus T. So now if we see here, so we will get T minus 20 equals to 176 into 0.653 divided by 56 divided by 0.745, so it will come 2.75 100 minus T. So T minus 20 equals to 275 minus 2.75 T. So 3.75 T equals to 295. So T equals to 295 divided by 3.75. So 295 divided by 3.75, it will come 78.7 degrees centigrade. So the final temperature will be 78.7 degree centigrade. Like volume of gases. So volume of nitrogen at 20 degrees centigrade, or we can say that 20 plus 273 is to 293 Kelvin. So that is suppose V1. So V1 I can write the moles, that is you can say that N1 or T1 by P1. So in that case N1, that is mole of the nitrogen, it is 2. Universal gas constant 8.314. Temperature is 293 and pressure, it is mentioning here 200 kilopascal. 200 kilopascal. So if we calculate this thing, it will come 24.36 meter cube. Similarly, volume of carbon dioxide at 100 degrees centigrade means 100 plus 273 equals to 373 Kelvin. That is V2. So for V2, we can write N2 or T2 by P2. So here N2 is nothing but moles of the carbon dioxide. It is 4 into R, that is 8.314 universal gas constant. T2 in that case is 373 and P2 pressure in that case is 100 kilopascal. So it is coming 124 meter cube. So now total volume plus to V equals to V1 plus V2. So the total volume will be 24.36 plus 124. So V will be 148.4 meter cube. Similarly, total number of moles equals to N1 plus N2, that is N. So N1 is 2 plus N2 is 4, it will be 6. Now final pressure equals to P equals to nRT by V. So here for final pressure, N is 6, R is 8.314. Temperature, final temperature we have already calculated 780.7 is in degree centigrade, but we want in Kelvin, so 273 divided by volume we have already calculated 148.4, and if we calculate this thing, it is coming 118.2 kilopascal. So the final pressure is 118.2 kilopascal. I am taking another problem. So first I am writing the problem here. A mixture is composed of a mixture is composed of 2 moles of carbon dioxide, 2 moles of carbon dioxide and 4 moles of nitrogen and 4 moles of nitrogen. It is compressed adiabatically adiabatically in a cylinder from 100 kilopascal from 100 kilopascal and 20 degrees centigrade to 2 megapascal, assuming constant constant specific heats assuming constant specific heats. Calculate the calculate the final temperature final temperature. CV for nitrogen is 0.745 kilojoule per kg Kelvin, and CV for carbon dioxide equals to 0.653 kilojoule per kg Kelvin. Similarly, Cp for nitrogen equals to 1.042 kilojoule per kg Kelvin, and Cp for carbon dioxide is 0.842 kilojoule per kg Kelvin. Let's solve the problem. So I am writing the solution here. So first of all, I will calculate mass of CO2 and mass of nitrogen. So mass of CO2 equals to M1. It will is number of moles into molecular weight. So number of moles for carbon dioxide is 2 and molecular weight it is 44. So it is coming 88 kg. Similarly, mass of nitrogen is to M2 equals to number of moles into molecular weight. So here we have to take number of moles and molecular weight corresponding to nitrogen. So M2, number of moles of nitrogen is 4, molecular weight is 28. So now 4 into 28 will come 112 kg. So the total mass, that is mass of mixture will come M1 plus M2. So 88 plus 112, it is coming 200 kilogram. So the mass of the mixture is 200 kilogram. Now in that problem, CV, it is specific heat at constant volume and constant pressure is given for carbon dioxide and nitrogen. So we have to find out for mixture. So now I am finding CV of mixture. CV of mixture, I can write M1, that is CV of nitrogen plus M2, M1 CV of carbon dioxide plus M2 CV of nitrogen divided by N. So here it is CV of mixture we'll get M1, we are having 88. CV of carbon dioxide is 0.653 plus M2, that is 112. And CV of nitrogen, it is having 0.745, and total mass here it is 2. We simplify it, we will get CV equals to 0.705 kilojoule per kg Kelvin. That is the CV of the mixture. Similarly, we can find out Cp of mixture. Cp of mixture, we can find out by M1 Cp into carbon dioxide plus M2 Cp of nitrogen divided by M. So now Cp equals to M1, we are having 88 into Cp of carbon dioxide is 0.842 plus M2 of nitrogen is 112, and Cp of nitrogen it is 1.042, that is 1.042, and if we calculate this thing, it is coming, Cp of mixture is coming, that is, and it should be divided by 200. If we calculate this thing, then Cp of mixture is coming 0.954 kilojoule per kg. So now we are having Cp, it is 0.954 kilojoule per kg Kelvin. Calculate gamma for mixture. Gamma for mixture. So gamma for mixture will be Cp by Cv. So we have calculated Cp is 0.954 and Cv is 0.70. So the Cp and Cv we will take for mixture, that is 0.954 divided by 0.705. So it will come 1.353. So the gamma for mixture will come 1.353. It is gamma for mixture. Now in this problem, we have to find out the final temperature, and the compression is adiabatic compression. So for adiabatic process, we are having the relationship between temperature and pressure. So I can write T2 equals to T1, T2 by P1, gamma minus 1 by gamma. So here we have to find out final temperature T2, T1 initial temperature, it is given 20, so 20 plus 273. Final pressure, it is given in the problem, that is 2 megapascal. We have to convert into kilopascal, so 2000 kilopascal. Initial pressure is 100 kilopascal. Gamma minus 1, that is 1.353 minus 1 divided by 1.35. If we calculate these things, then we will get T2 equals to 640 Kelvin. So the correct answer is 640 Kelvin. Another problem. So I am writing the problem first. Heat is supplied to a gas. Heat is supplied to a gas and it moves from state x to y. Find the amount of unavailable energy. So the options are given here. A, it is T0 Sx. B, that is Qxy minus T0 Sy minus Sx. C, that is T0 Sy minus Sx. And D, that is U minus T0. So for this problem, if we go through our previous discussion about availability and irreversibility, then we can understand we have already discussed the unavailable energy is product of ambient temperature into entropy change of the process. Here in C option, we are seeing ambient temperature, that is T0, and Sy minus Sx, that is entropy change. So the correct answer is C, it is T0 Sy into Sy minus Sx. The correct answer is C.